Morning, good evening. This is Mr. Rivera, and I'm here to talk about topic two, EQ1, uh, particularly exercise 5, which is projectile motion with air resistance under the aerospace mechanical engineering disciplines. So to start off, I'm going to talk about why this makes me a better engineer. The reasons why I believe this makes me a better engineer is because it allows you to start thinking how you can model real world systems in a mathematical sense, right? As a result, you learn to practice between analytical and numerical methods. It allows development of intuition around, for this particular scenario, forces, interactions, and overall system behavior being in the atmosphere. It allows to compare models, ideal versus real, analytical versus numerical. And more importantly, it builds problem solving habits that allow assumption definition, equation derivation, validation, analyzation of analyzing the impact of parameters and overall just cause and effect, in contrast to being able to um, drive different test cases with masses and environmental conditions. You're able to model trial and error with less investment. It's time investment and less cost investment. So let's go over the MATLAB code and what it intends to do. So start off, let me go here to first command. This is just to clear the workspace. We're now in B section is going to start defining some of the constants, some liberties we're taking here, such as C is the air resistance coefficient. We're then going to move into defining initial conditions for the variables, initialization to 0 or initial conditions such as 50, particularly initial speed. Theta 45 would be the initial launch angle. We're then going to move into converting speed for some of the velocity components. We're then going to set up the ODE system for the study of drag, motion with drag. Do we get those particular declarations? You're then going to move into solving with the ODE 45 MATLAB function. We then move into evaluating the numerical solution. We extract the positions with these two lines of code. And now we move into doing the same, but with a no drag ambient condition. So we start with understanding the physics formulas for that. We remove the negative heights, this section. Then finally, we plot both trajectories in order to be able to visually make a decision on whether we want amplitude or whether we want distance magnitude. So this code basically summarizes, simulates 2D projectile motion with drag, without drag, comparison to trajectories, and it allows further visualization of the effect of air resistance on both of the parameters that I established, distance and height. That is all for today. Thank you.